In this video, I'm going to discuss about solving polynomial inequalities where the degree of the polynomial is greater than 2. I'm going to focus on two methods. One is by using graphical method and another one is by using algebra method. Now let us try the first question. Find the set of values of x such that this polynomial is greater than or equal to 0. First, I try to solve this inequality by using graphical method. To do this, of course, we need to sketch the graph. Before sketching the graph, the very first step is we need to factorize the polynomial completely such that the polynomial is converted into the form of linear factor. In my previous video, we have learned how to do factorization by using factor theorem. I suggest you watch the video first before continue. After factorization, the polynomial should be converted into the form of linear factors like this. Now, I can start sketching the graph. And I have another video discussing about how to sketch the graphs of polynomial functions. If you haven't watched the video, you are suggested to watch the video first. After sketching, the graph should be something like this. Next step, I'm going to mark the region of the inequality. Since the inequality is greater than or equal to 0, then the part of the graph which is above the x-axis should be marked. Then we should double check whether the critical values are included. In this case, they are all included because the inequality is greater than or equal to 0. Based on the graph, then the solution is x is greater than or equal to -1 and less than or equal to 2, or x is greater than 7/2. Now I'm going to solve this inequality without using graph. First, similarly, we need to factorize the polynomial. After factorization, I got 3 linear factors. From the linear factors, I got 3 different roots. One is 7/2 from the factor 2x minus 7. One is -1 from the factor x plus 1. And another one is 2 from the factor x minus 2. Now I'm going to mark these 3 different roots on a number line from -infinity up to +infinity. Notice that the number line has been divided into 4 regions. The first one is from -infinity to -1. The second region is from -1 to 2. The third region is from 2 to 7/2. And the fourth region is from 7/2 to +infinity. For each region, I'm going to test the value of the polynomial. First, I start from the first region. In this first region, one value of x is chosen from -infinity to -1. This value of x is then substituted into the polynomial. Let's say -2 is chosen. When -2 is substituted into the factor 2x minus 7, then I got -11. When -2 is substituted into the factor x plus 1, I got -1. When negative 2 is substituted into the factor x minus 2, I got negative 4. The overall value is a negative value which is less than 0. This result shows that the polynomial is less than 0 when x is less than negative 1. Next, I'm going to test the second region, from negative 1 to 2. In this region, one value of x is chosen, say 0. When 0 is substituted into the factor 2x minus 7, then I got negative 7. Into the factor x plus 1, I got 1. Into the factor x minus 2, I got negative 2. The overall value is a positive value which is greater than 0. This result shows that the polynomial is greater than 0 when x is between negative 1 to 2. Now I'm going to test the third region from 2 to 7 over 2. In this region, one value of x is chosen. Let's say 3 is chosen. When x is 3, 2x minus 7 is negative 1, x plus 1 is 4, x minus 2 is 1, then the overall value is a negative value which is less than 0. So this result shows that the polynomial is less than 0 when x is between 2 to 7 over 2. The last region greater than 7 over 2. In this region, one value of x is chosen. Let's say 4 is chosen. When x is equal to 4, 2x minus 7 is 1, x plus 1 is 5, x minus 2 is 2. The overall value is a positive value which is greater than 0. This result shows that the polynomial is greater than 0 when x is greater than 7 over 2. So conclusion, since the inequality is greater than or equal to 0, then the solution is the second region and the fourth region. Last, remember to double check whether the critical values are included in the solution. In this case, all the critical values are included in the solution because the inequality is greater than or equal to. Finally, write the answer in set notation. Next example, find the set of values of x such that this polynomial is less than 0. In this question, notice that the coefficient of the highest power is negative. Normally, in this case, I prefer to change it to positive by multiplying the inequality by negative 1. If we do this, the inequality will change from less than 0 to greater than 0. This will reduce the chances of making mistakes in the following working steps. But it is alright if students prefer to continue without any changes. Next, I'm going to factorize the polynomial by using the technique of factorization which we have learned before. After the factorization, then I got 2 linear factors and 1 quadratic factor. This quadratic factor can be further factorized into a repeated linear factor. Now I'm going to use graphical method to solve the inequality. So I need to sketch the graph. By using the technique of sketching that we have learned before, after sketching, now the graph looks like this. Then I'm going to mark the region of the inequality. Since the inequality is greater than 0, then the part of the graph which is above the x-axis should be marked. Remember to double check the critical points. Since the inequality is greater than 0, so the critical points are not included in the solution. Therefore, the solution is x is less than 1 over 2 or x is between 1 over 2 to 2, or x is greater than 3. Now I'm going to solve the inequality without using graph. From the factorization, I got 3 linear factors, where 1 is repeated factor. From the linear factor, then I got 3 different roots. One is 3 from the factor x minus 3, one is 2 from the factor x minus 2, and the other one is 1 over 2 from the factor 2x minus 1. Now I'm going to mark these 3 different roots on a number line, from negative infinity up to positive infinity. Notice that the number line has been divided into 4 regions. The first region is from negative infinity up to 1 over 2. The second region is from 1 over 2 to 2. The third region is from 2 to 3. And the fourth region is from 3 to positive infinity. For each region, I'm going to test the value of the polynomial. In the first region, one value of x is chosen. Let's say 0 is chosen. When x is equal to 0, x minus 3 is negative 3, x minus 2 is negative 2, 2x minus 1 is 1. So the overall value is a positive value which is greater than 0. This result shows that the polynomial is greater than 0 when x is less than 1 over 2. Next, I'm going to test the second region from 1 over 2 to 2. One value of x is chosen. Let's say 1 is chosen. When x is 1, x minus 3 is negative 2, x minus 2 is negative 1, 2x minus 1 power 2 is 1. The overall value is a positive value which is greater than 0. So this result shows that the polynomial is greater than 0 when x is from 1 over 2 to 2. Then I'm going to test the third region from 2 to 3. One value of x is chosen. Let's say 2.5 is chosen. When x is 2.5, x minus 3 is negative 0.5, x minus 2 is positive 0.5, 2x minus 1 power 2 is 16, and the overall value is a negative value which is less than 0. So this result shows that the polynomial is less than 0 when x is in between 2 to 3. Then the last region. One value of x is chosen. Let's say I choose 4. When x is 4, x minus 3 is 1, x minus 2 is 2, 2x minus 1 power 2 is 49, and the overall value is a positive value which is greater than 0. This result shows that the polynomial is greater than 0 when x is greater than 3. So conclusion, since the inequality is greater than 0, then the solution is the first region, the second region, and the fourth region. Last, remember to double check whether the critical values are included in the solution. In this case, they are not included in the solution because the inequality is greater than. So finally, write the answer in set notation. Next example, find the set of values of x such that the polynomial is less than or equal to 0. First, I try to use graphical method. Then I need to sketch the graph. When sketching the graph by using the technique that we have learned before, the polynomial should be in the form of linear factor. Notice that in this polynomial, I have one linear factor and one quadratic factor. So, before sketching the graph, I need to further factorize the quadratic factor such that the polynomial is in the form of linear factors. After factorize the quadratic factor, now the polynomial is in linear factor form. So now I'm ready to sketch the graph. After sketching the graph looks like this. And since the inequality is less than 0, then the part of the graph which is below the x-axis should be marked. Based on the graph, then the solution is x is between negative 1 over square root of 2 to positive 1 over square root of 2, or x is greater than 3. Now I'm going to solve the inequality without using graph. From the factor 3 minus x, the root is 3. From the quadratic factor 2x power 2 minus 1, I got two roots. One is negative 1 over square root of 2 and one is positive 1 over square root of 2. Now I'm going to mark the three different roots on a number line. And the number line has been divided into 4 regions. For each region, I'm going to test the value of the polynomial. For the first region, I choose x is equal to negative 1. When x is equals negative 1, 2x power 2 minus 1 is 1. 3 minus x is 4. So, overall value, it is a positive value which is greater than 0. So, the polynomial is greater than 0 in this region. The second region, I choose x equals 0. When x equals 0, 2x power 2 minus 1 is negative 1. 3 minus x is 3. So, the overall value is a negative value which is less than 0. So, the polynomial is less than 0 in this region. The third region, I choose x equals 1. So, when x equals 1, 2x power 2 minus 1 is 1. 3 minus x is 2. So, overall, it is a positive value which is greater than 0. So, means the polynomial is greater than 0 in this region. Then the last region, I choose x is equal to 4. When x is 4, 2x power 2 minus 1 is 31. 3 minus x is negative 1. So, overall, it is a negative value which is less than 0. So, the polynomial is less than 0 in this region. Since the inequality is less than or equal to 0, then the solution is in second and fourth region. And we found that the critical values are included in the solution. So therefore, the solution is x is less than or equal to 0 when x is between negative 1 over square root of 2 to positive 1 over square root of 2, or when x is greater than 3. Next example, find the set of values of x such that the polynomial is less than or equal to 0. This polynomial consists of 2 linear factors and 1 quadratic factor. But this quadratic factor cannot be further factorized into the linear factor. And when I try to find the root from this quadratic factor, I found that there is no root can be found from this quadratic factor. However, notice that this quadratic factor is always positive for all the real values of x, which means that this quadratic factor can be ignored. But when we do this, the reason must be written during the examination. After the quadratic factor is ignored, then we only focus on the 2 linear factors to find the solution. Now, the inequality becomes a quadratic inequality. The shape of the quadratic is an N shape because the coefficient of x power 2 is a negative. The shaded region is below the x-axis because the inequality is less than or equal to 0. So finally, the answer is x less than or equal to 2 or x greater than or equal to 3. Next example, find the set of values of x such that this polynomial is greater than 0. Since this polynomial consists of one quadratic factor, so I'm going to factorize the quadratic factor. But I found that it couldn't be done. In this case, I can use completing the square. After completing the square, then I got something like this. Notice that this factor is always positive for all the real values of x, then which means that this factor can be ignored. And now I only need to focus on x minus 2. When x minus 2 is greater than 0, then x is greater than 2. Then the solution is x greater than 2, and remember to write it in set notation. Next example, find the set of values of x such that this polynomial is greater than 0. Similarly, this inequality consists of one quadratic factor. Since factorization cannot be done, so I'm going to carry out completing the square. After completing the square, I got something like this. And after completing the square, I found that this quadratic factor can be factorized by using the formula here, where a is equal to x plus 1 over 2 and b is equal to square root of 5 over 2. So when I factorize, then I got this one. So this is a plus b and multiply with a minus b. So after simplify, I got 3 linear factors. Now I'm going to solve the inequality by using graphical method. And after sketching the graph, the curve looks like this. Since the inequality is greater than 0, so the part of the graph which is above the x-axis is marked. So based on the graph, then now this is the solution for this inequality.